let's go with a bit specialized EMS, which we developed since, I think, over 5 years now, because we started with the laboratory, with cooperation with university. Then we did small laboratory in our facility to see how we can manage the system more proactively in our conditions. But as Elsza, few words about us, because I'm pretty sure not everyone knows us. Our boss would like to mention that we are on the market almost 40 years, 37 to be exact. We are present in 30 countries, but it's mostly export of our products. And we have around over 300 employees. We can offer turnkey projects. That's why we have the design, production, delivery completion, automation, which is done on Zenon. I will explain why. Programming works, which are, let's say, on top of the Zenon and this IT infrastructure, which is ongoing right now. Commissioning, which is making sure that everything what we do ends up running and it's a finished product. Maintenance to keep it going, and also installation works across many countries in Europe mostly. So regarding the products, we do LV switchgear, medium switchgear, the cabinets for SAS, IO. We do transformer station. We also have our own product, which is energy storage solution with our components. We got e-houses, which are the electrical houses where we fit in all this LV switchgear, MV switchgear, and some components which we buy from the market. So it's like electrical building made from steel. We also have active filters, inverters, so we can make a lot. But in this case, I will speak about one example of a project where we just did automation. But as you can see, this was done in Poland, in Zawiercie. But EMS in this kind of project is the most important part, because without this, these are just blocks. They cannot communicate with each other, they cannot communicate with the grid. So we were doing their only automation. Our partner was Vast Energy, which was providing all these blocks, transformers, PV. And the client is Elemental Strategic Metals, which is company which is removing the rare materials from the electronics, so like gold, platinum, and more interesting is how they do it. They have electric arc flash furnaces, so that's problematic for this kind of project because each one of them is like 2 megawatts. So you either have load or you don't have load. You need to interact. And the problem on this project was that they had net zero to the grid. So they need to compensate everything or just prove that they are off-grid solution. They also installed PV station, which is almost 12 mega of the megawatt peaks, which was 32 inverters, which we had to connect, parameterize, and we interact with. Energy storage, like I said, we didn't provide our solution, but here there was 7 containers. The total power was 14 megawatts. And we also had to make sure that all loggers which are incorporated in this are working properly. So main functions of this EMS, as you know, there's communication with PV loggers, a battery energy system, MV switchgear, and also existing system, because there was existing SCADA, which we need to incorporate a lot of data in order to be proactively, to plan, to predict the conditions. This is, I would say, shortcut, because EMS is not contacting directly all of these devices. I would like to say that we are SDA application already, but we had to put some hardware and we utilized the RTU to exchange the information together, to change the protocols. So Zenon is more for acquiring this data. We put some algorithm above the zenon due to its functionality for the extensions. We could put even C# algorithms over it. Then you got data exchange with the energy provider, which is also realized more by RTU. Monitoring, control, data, acknowledgement, archiving the data, which at the beginning when we started, even though it looks like not so big project, there was few gigabytes of data each day because we need to make sure which data are already fine. So at the beginning we gathered all of them, tested which can be skipped. So now it's a lot optimized, but it's still a lot of data every day. And the main factor for this project was energy cost management, because it's all about return of investment. And here I would like to present you two slides, simple slides which we've made. One is for sunny day, the next one will be for the worst condition. And like I said, it was zero export, but when we calculated the values of current transformers of the analyzers, we checked the error, it summed up to 300 kilowatts, which can occur because it's due to the measurement error. But actually, in last year, we rarely went above few kilowatts. So it was quite nice achievement. There was only a few days where there were really not planned outages, where we had a bit more than few, but never 300 kilowatts. And here you can see it's pretty nice condition where PV goes on straight in morning. You got a whole load covered by this PV. Green line is the BESS, which is charging. It's fully charged already in the morning, and then in the evening when the sun goes down, you can utilize this energy. It goes through the night, and then PV goes on, and it's like synergy. It's visible, but as you know, we are not living in the perfect world, so there are days which are cloudy or even more than cloudy, and then we got situations like this that storage is already out of the energy. There is consumption. We need to take a decision if we using grid. In this case, the algorithm said it's better to use grid. Then we had, in this case, charging of the battery system started when in previous case it was already loaded. So at 10 it was already full. Here we just started, so it was not managed to reach 100% by the end of the day. In the meantime, he needed to struggle with some changes on the factory floor. So there was some peak shaving, maybe even load shedding ongoing. So there was discharging process. And in this case, you can see that we never achieved perfect condition. That's why we added more functionalities for the client, since the program is working automatically. But the client said, maybe I can do it better. As clients always think that they are smarter than the algorithms, we added a lot of manual functionalities. So manual scheduling for hours. We added also them all visualization of all parameters. They can even change some of them from zenon. We added manual control of the strings because they said that they will play with strings. We thought that it's also good for maintenance. So everything which we did on the program, which is automatically ongoing, it doesn't need any assistance from the client, currently was moved to manual mode. And the client is trying to play with, see how it goes every day, compare the values. So far, I would say it's good, we are winning, but we will see if it will stay like this. So, the rest of the thing is quite standard. You got monitoring of the energy for each cell, for each string. You got predictions of the weather, you got weather forecasts. You got the values from the battery storage systems to manage the functionality, to manage the faults. Then you got all logs, which are, let's say, standard in Zenon and quite handy out of the box, but we always tweak them a bit. So all of this is provided thanks to Zenon. On this project, we did other improvements like peak prediction, then also expense monitoring and energy trading, but this is not utilized yet due to the factors which are limiting the client, because the grid operator needs to give them special authorization, change the contracts. So we already prepared some things, but we cannot implement them on this project because of this net zero energy to the grid. But the very important thing is savings. The savings, I would say, were more than expected. I cannot give values because the client said that we cannot share it. I can just tell you that they are looking to double the capacity of their system. So as already said, it was 14 megawatt storage in the energy storage. Now they want to double it at least, because they found out that not only production of PV is helping them, not only playing with the energy, which is currently quite limited because they cannot sell, they can just buy it and use it in the right time. But they also found out that they had real issue with reactive power consumption, and due to the characteristic of the battery storage system, it was corrected a lot by default, I would say, and the most savings which they achieved was just from this feature, and they were quite surprised how their system was not optimized on this field, and the return on investment will be really, really quick. So this was about the project which we did last year, which was quite demanding because the schedule was tight. Currently, we are doing more projects also in Poland, one in Jasło, another in Bytom, where these projects are a bit smaller, but we are providing our energy storage solution over there. We are doing the electrical works, commissioning, we are doing the automation, so we adapted the system which was developed in Zawiercie. And these projects have extra features, I would say, requested by client, which I put here. So on Jasło, they ask us to compensate the reactive power with the PV inverters. They also ask us to interface with the balancing market because they have different type of agreement with the markets. So over there we can play with the energy on daily basis. It's still not during the day because in Poland law is changing. We are expecting it to take almost 2 years from now to change completely, but we already can interact. So we got this link with the trading platforms, and we can play with selling and buying energy. Also, on Bytom, there's another feature, which is off-grid island mode, but only partially. They want to make sure that only part of the energy, which is provided by the energy storage system, will be off-grid always. The rest needs to be available. So it's like hybrid solution in between these three projects. And this is something new, which we didn't develop before. So this was developed just for this project and gonna be tested, I hope, next month. So keep fingers crossed for us. And that's everything from my side. If you want, we can talk after the presentation. If you want, we can also reach us by rfq@elsta.pl and we can share more details. Thank you.